let's consider the field due to an arc of charge. So let's imagine that we've got a wire, current's going down the wire, and then it takes a right-hand turn, it makes an arc, and then current goes out, like that. Okay, so there's the current going through here. This arc is a fraction of a circle, and it has radius r, so I want to know what's the magnetic field right there at that point that is the center of the radius of curvature. Okay. All right. So, how do we do that? Well, we've got three parts here. We've got part A, part B, part C. So the magnetic field at this position right here, that magnetic field is going to be, the sum of those three parts. Now, the really nice thing about this is that because this is going straight in and straight out, we know the magnetic field straight in and out from a current. In other words, there's no forward or reverse magnetic field, so that means those two magnetic fields are zero. Okay, so that means all we have to do is figure out the magnetic field of this arc. So we're going to assume that arc is some angle phi right there. Okay, so how will we find the magnetic field there? Well, the magnetic field is going to be the integral of the differential field. So that's going to be the integral of the mu naught over 4 pi I ds cross r hat over r squared. Okay, so the Biot-Savart law. Okay, so first of all, the ds cross r hat is just going to be ds. Okay, because r hat's going to be perpendicular to the ds. So the b, we got mu naught I over 4 pi. Now the r is just going to be the radius of the arc. Well, since it's a circular arc, that's constant, so that comes out of the integral, and so this is just going to be integral ds. Well, integral ds is just s. That's the distance around that arc. Well, what's the distance around an arc? Well, that's going to be equal to the distance around an arc is going to be r times the angle. So the magnetic field is mu naught I over 4 pi r squared r times the angle. So that cancels that. So the magnetic field, mu naught I phi over 4 pi r. Now, direction, it was doing that. So the current was going that way. Right-hand rule, you point your thumb in the direction of the current, your fingers are going to point this way. So that means for this particular example right there, the magnetic field is going to be into the screen. Okay. Okay, now, very, very important. Phi. It must be in radians. So the phi must be in radians. It will not work if you put that in degrees. So that must be in radians. Okay. So that's how you basically do this. This is the magnetic field of an arc.